In this tutorial, we're going to take a look at some properties of exponential functions. So first of all, we need to graph them to see a lot of these properties. So we're going to make a table of values here, and I use -3 to 3 for the x values. I could use different numbers. I could use decimals if I wanted to, but generally a few positives, a few negatives will give you a pretty good idea what the graph looks like, unless it's been, of course, translated a long ways right or left or up or down. So this is going to be the graph of y equals 2 to the x, and then 3 to the x, and y equals 4 to the x will be the third one. So the first one here, we're going to evaluate 2 to the power of -3. And I'll write up the first value. It's 1/8. And I want to show you where that comes from. And so when I substitute this -3 in place of x here, so this is what I'm actually evaluating. I'm going 2 to the power of -3. And remember, a negative exponent means the reciprocal. So this is the same as 1 over 2 to the power of +3. 2 to the power of +3 is 2 times 2 times 2, which is 8. So that's where the 1 over 8 comes from. The next one, we're going to put this -2 here in place of x. So we would evaluate 2 to the power of -2, which is 1 over 2 to the power of +2, and that means 2 times 2 or 4, so we get 1 over 4, or a quarter. So the next one will be a quarter, and then 2 to the power of -1 would be 1 over 2, which is a half. 2 to the power of 0, anything to the power of 0 is 1, except you can't raise 0 to the power of 0. We put 1 in here. 2 to the power of 1 is 2. And then put 2 in here. 2 squared is 4. And then 2 cubed would be 8. And so if we plot these points, so -3 comma 1/8, it would be -3 and up. Now 1/8 is pretty hard to graph. It's just like barely above 0. Some of these points might not look like they're exactly on. That could have headed over a little bit, but it's difficult to put these points exactly where you want them, especially for fractions like 1/8 high. -2 to the -2 comma a quarter is just a slightly higher. -1 a half would be about there. 0, 1 would be about here, and then 1 comma 2 would be this point right here. And then we have 2 comma 4, so over 2 and up 4. And then 3, 8 is the next point, so over 3 and up 8, which of course would be right up here. Oh, that should be just a little bit higher. There, that's a little bit better. And so this is what the exponential curve y equals 2 to the x looks like. So let's put the equation, I'll put the equation on in a moment. So the next one, I'm going to actually just get rid of these fractions here. So next we would have, we're substituting, we're going to do the 3 to the x graph. So I'm substituting this -3 in place of x here. So we would go 3 to the power of -3, which is 1 over 3 to the power of +3. And that means 3 times 3 times 3, which is 27 in the denominator. So that's where the 1 over 27 comes from. Next, I'm going to put -2 in place of x. So we would go 3 to the power of -2, which is 1 over 3 squared, or 1 over 9. So that would be the next one. So that's the idea. So 3 to the power of -1 is a third, or 1 over 3 to the first. 3 to the power of 0, just like 2 to the power of 0, is 1. And then if I put 1 in place of x, 3 to the power of 1 is 3. And then if we put 2, 3 squared is 9, that's 3 times 3. And then of course 3 to the power of 3 would be 27 for the last one. I can't really plot that one because it's off the top of the graph a long ways. So -3, 1 over 27, so -3, 1 over, so it's just basically right around 0 here. And then 1/9, pretty hard to tell the difference graphically between 1/9 and a quarter. And then a third, so there's that point. It looks pretty much the same as the last one, -1, a third. 0, 1, of course, you're going to see a point come in right here, that's 0, 1. And then 1, 3 would be the next one, so over 1, up 3. 2, 9, so over 2 and up, well, it should be right about there. Maybe we'll fix that one too. And that looks a little bit better, so let's draw our curve in here now. So that's what the 3 to the x, y equals 3 to the x function looks like. So next one, we're going to put negative 3 in place of x here. So 4 to the power of negative 3 works out to 1 over 64. It's actually 1 over 4 cubed, and 4 cubed is 64. And then we get 4 to the power of negative 2 is 1 over 16. 4 to the power of negative 1 is a quarter, or 1 over 4 to the first. 4 to the power of 0 is 1, just like all these were. And then put 1 in here. 4 to the power of 1 is 4. And then 2, 4 squared would be 16. And then 3, 4 cubed is 64. And so we'll plot these points. So there's the negative 3, 1 over 64 is very close to negative 3, 0. It's just slightly above the x-axis. And then negative 2, 1/16 is still pretty low here. Negative 1 1/4, pretty much right there. And then 0, 1, of course, same point as this one. And then 1, 4. So 1, 4 is going to be about right here. And then 2, 16 now over 2 and up 16. So that's 11, 12, 13, 14, 15. So about right there. And I can't plot the 364 because it's way too high up there. But we can join those together. So that's what the y equals 4 to the x graph looks like. So let's label these. That's the first one. That's the 3 to the x graph. And that's the 4 to the x graph. So that's what the shape of the exponential function looks like. And what we're going to do in the next page is look at the bases here are fractions. And specifically, we're going to graph a half to the x, 1/3 to the x, and 1/4 to the x to see how they relate to these graphs. So the half to the x. So I'm going to put negative 3 in place of x here. And so I'm going to do this first calculation here. So I'm evaluating a half to the power of negative 3. Well, remember, the negative exponent means the reciprocal. So this is the reciprocal of a half. This is one of the ways to evaluate this. I can take the reciprocal of a half, which is 2 over 1, and raise it to the power of positive 3. So that is the same thing. And so this is really just 2 cubed over 1 cubed. Now, 1 cubed in the denominator is just 1. So it's really just 2 cubed. Which would equal 8. And if you have your calculator, you can actually do that in your calculator too. Let's just bring the calculator over here. See, I'm actually evaluating 1 over 2, just to show this works with the calculator, to the power of negative 3, and it'll give me exactly 8. So you can do that in your calculator as well. So this first y value would be 8 here. And then the next one, when we do put the negative 2 in place of x here, it's going to look like this. It would be a half to the negative 2, which would be the reciprocal of the half to the power of positive 2. So basically, it's 2 squared, which is 4. Now, if you want to write the 1 on the bottom, okay, it's 1 squared, but 1 squared is 1, so 4 divided by 1 is still just 4. So that's why I just dropped the denominator, because it's 1 anyway. So there's a 4 there. And then the negative 1, we put negative 1 here. The negative 1 exponent just means the reciprocal of a half, which of course would be 2. 0, a half to the power of 0, just like all the ones on the last page. And the power of 0 is 1, except you can't raise 0 to the power of 0. Notice what we're doing here is you're actually dividing by a 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So the next one should be a half. And you see, if I put 1 in place of x here, a half to the power of 1 would be a half. If we put a 2 here, 1 squared and the top is 1, and 2 squared and the bottom will be 4, so that's a quarter, and then the last one's 1/8. And so we can plot these points. So negative 3, 8, so negative 3, 8 would be right there, and then negative 2, 4 would be about right there. Negative 1, 2 would be right here, and then 0, 1 would be right there. 1 comma a half over 1 up a half, so about right there. And we're getting, again, to small y values. 2 1/4, it's just barely above the x-axis here. And then 3 1/8, something like that. and we join them together. And one of the comparisons I'm going to draw here is notice how similar that is to the 2 to the x graph. In fact, it's really just all the y values in reverse order. It's the same y values, just in a different order. So these are actually, this is the 1/2 to the x graph. They're actually reflections of each other in the y-axis. And that's because of the fact that 1/2 and 2 are reciprocals of each other. So the 1/3 to the x, if you plug a -3 in here, it's going to be the same as 3 to the power of positive 3, which is 27. And again, the same values as the previous page. Not going to go through all of these. Same idea. And if we plot those, now we can't plot the -327 because it's way too high up there. But -2,9 would be about right here. And then -1,3 is about right there. And then 0, 1 is right here, and then we get the 3 other points very similar to these. And so that's the points plotted. We join them together, and we see they have a curve that's the exact reflection in the y-axis of the 3 to the x function. So that's the 1/3 to the x function. And similar idea, again with the quarter, I'm just going to put up all the values here. If you want to pause the video to copy that on, if you're taking notes, you can. Again, same y values as the previous page, just in the opposite order. So if we plot these, and I can't plot the 64 one because it's too high, but -216 was that one, and then -1,4 would be this one, and then 0, 1 would be right here, and then 1, 1/4 is about right there. And then 2, 1/16 is about right there. And 3, 1/64 is about right there. So we join them together. And that's the 1/4 to the x graph. And notice that again, it's the reflection in the y-axis of the 4 to the x graph that we graphed on the previous page. So that's how you can draw exponential functions. And I'm going to flip the page here now. And so here's some comparisons, some basic features of exponential curves, and some of the things they have in common. So number one, they all have a horizontal asymptote of the x-axis, or the line y = 0. And what an asymptote is a line that the graph gets really, really close to but never ever touches. Graphs actually can cross horizontal asymptotes, but they can. There's actually vertical asymptotes too that we won't bother with here because exponential functions do not have vertical asymptotes. But basically, an asymptote is called, it's like a limiting function. It's a line that the graph gets really, really close to as x becomes really large, or a really large negative this way, or a really large positive in this direction. So they all have this horizontal asymptote, and that's because of the fact that no power of either a whole number or a fraction can ever equal 0. It can get really close to it, but it can never actually equal 0. Now, we talk about the asymptote going in what direction. So for the first graphs, these with the base 2, 3, and 4, the asymptote extends only to the left. So if the base is between 0 and 1 here, like the ones we just drew on the last page, the asymptote extends to the right side. There is no asymptote for these ones towards the left because they get really, really large here. So if the base is a number larger than 1, the asymptote extends to the left. If the base is a fraction or a decimal between 0 and 1, or I guess a root or something like that, then it extends to the right. They all have y-intercepts of 1, go through the y-axis of 1, since a to the power of 0 is 1 for any value, except of course you can't do 0 to the power of 0. Y = a to the x and 1 over a to the x are reflections of each other in the y-axis. And all of these functions have the same domain and range. The domain is the entire set of real numbers. There's no number you can't substitute in place of x for any of these. You can evaluate any number to the power of some other number, big or small, doesn't matter. But they all have restrictions on the range. Notice that y is never 0. If you go back and look at those tables, it's always a positive value, because if you have a positive base and you raise it to any number, it's always going to be bigger than 0. So the range is all real numbers greater than 0. And one last page here. The 3U course that this video is intended for it's called the functions course. In our grade 9 courses in Ontario, we start talking about the linear function, and this is the most basic linear function, f of x equals x or y equals x. And so here's points on it, y equals x, so the y and x coordinates are the same. And so if you take a look at the change in y as you go from point to point, y is always going up, in this case by 1, the same number. So from -2 to 1 it goes up by 1, from -1 to 0 it goes up by 1, from 0 to 1 it goes up by 1. And from 1 to 2 it goes up by 1. So then those are called the first differences, and if the first differences are all the same, it is a linear function. They don't always have to be 1, but as long as they're the same thing, even a negative value, that's okay. It's still a linear function. Now for the quadratic function, and I've plotted a few ordered pairs here, -2, 4, -1, 1, 0, 0, and 1, 1, and 2, 4 up there. So notice, okay, this is the, and I'm going from 0, 0 to 1, 1 in the graph here, but I'm going to do the entire table here. So if you take a look at from 4 to 1, that's a change of -3. It goes down by 3. And then 1 to 0 goes down by 1. Now, what you see in the graph here is you go from this point to this point, the y value is going up by 1, because from 0 to 1, it increases by 1. From 1 to 4, it goes up by 3. That's that change of y. The next one would be 5. And notice that the differences aren't all the same like they were for the linear, because that's a quadratic curve. Now, if you take a look at the second differences, from -3 to 1, it goes up by 2. From -1 to +1, it goes up by 2. And from +1 to 3, it goes up by 2. And if those second differences are the same, that means it's a quadratic function. That's one of the characteristics of a quadratic function. Well, neither of those is the case for an exponential curve. An exponential curve, like if I take, and I'm going to write some of these in here. If I look at the differences, like from 1/4 to 1/2, that's gone up by 1/4. So if I wanted to write the first differences, it would be 1/4. From 1/2 to 1, it's going up by 1/2. From 1 to 2, it's going up by 2. From 2 to 4, it's going up by, whoops, I did that wrong. That's a 1 there. Just scratch that out. That's a 1. From 1 to 2 goes up by 1. From 2 to 4 goes up by 2. I was thinking about the next one. So first differences are not the same, it's not linear. If we wanted to think, well, what are the second differences? From 1/4 to 1, oh, it's still going up by 1/4. See if I can do this one right. From 1/2 to 1, it's going up by 1/2. From 1 to 2, it's going up by 1. So the second differences are also not the same. So it's definitely not a quadratic function. And so let's get rid of those. There we go. Go back to my pointer. So the characteristic of the exponential function is that there's a multiplier between all the y values. There's no common differences or second differences or third differences, anything like that. So if you take 1/4 and multiply it by 1/2, and maybe I'll do this one up here, and this is because of the base. Oh, I have a mistake here. This is supposed to be 2 to the x. Let's fix that. Yeah, so that's supposed to be the 2 to the x function, not the x squared. So if I take this 1/4 and multiply it by 2, now 2 is the same as 2 over 1. So that gives me 1 times 2 is 2, and 4 times 1 is 4. So that's 1/2. So you see, if I multiply 1/4 by 1/2, I get, 1/4 by 2, I get the next y value. So this is multiplying by 2. Now if I take this 1/2 here, this guy, and multiply by 2 again, that gives me 2 over 2, which equals 1, which is the next y value. So 1/2 times 2 gives you the next y value. And of course, this 1 times 2 again gives you that 2, and this 2 times 2 again gives you that 4. So there's a multiplying relationship between the function values. And that's one of the characteristics of an exponential curve. Because it grows so quickly, the y values are changing by different amounts. In fact, even the changes in y are related by a multiplying. See, this change in y is 1, this is 2, this is going up by 4. And that might be a little bit difficult to see here. It's actually supposed to be going up to that point right there. Again, it's a multiplying by 2 relationship between those, even the changes in y's, just like it is between the y values. So that's one of the characteristics of an exponential curve. And the shape is quite different from the quadratic and the linear. So that's some of the characteristics of exponential functions and how they are similar or dissimilar from the linear functions and quadratic functions. And that's the end of the tutorial.